All right, guys. So this is video problem number 2 now. I don't know why it always does that. There we go. Okay. Oh, man. There we go. All right, video problem number 2. So it wants to know how long was the ball in the air on the one that I threw up. So we're going to go back to Logger Pro. And now I'm going to insert the other video. So insert movie, desktop, ball thrown in gym. Nice. All right. So we're looking at this. I'm going to pull up my tools over here. Now, same deal.
Yeah.
All right, so I want to put one mark right when the ball leaves my hand. We'll say that's there. And then I want to put the next mark when it falls back into my hand. Man, look at that. Mr. McSparren is an amazing athlete. He's thrown that ball very high, straight up, and just perfectly right back into my hands. Jeez. Doesn't get much better than that, guys. Okay, so let's auto-arrange that. And again, I don't care about the graph. I care about the table. So I see that the ball left my hand at 2.819 seconds, and then it fell back into my hand at 4.471 seconds. So I'm going to put those down on my paper. So 4.471. Okay. So we're going to go delta t equals 4.471 minus, what was it? 2.819. 2.819. And that equals, let's go over here, and I'm going to go 4.471 minus 2.819. That's 1.652. All right, 1.652. 1.652. There we go. And that is seconds. So that's my delta t, the time that the ball was in the air. All right, now based on the time the ball was in the air, calculate the initial velocity. All right, so it's asking for VI. That's my question mark. Okay, so right away, let's go ahead and I know that I'm going to need to use this VF equals VI minus 9.8 delta t, because I don't know anything about how high it went yet. So I'm going to have to use this one. Now I know some information about VF, right? VF is going to be equal to 0. Let's remember why, okay? So we've got Mr. McSparren, okay? He throws the ball up. Well, if I'm going to the highest point, that means that VI was the beginning, VF was the end, because I'm only talking about it going to the highest point. I'm not talking about it going back down. So VF is 0 because we know at the highest point the velocity is 0. But the other thing that's important here is that delta t, okay? Delta t is not 1.652. Now the reason is that 1.652 was the time for all the way up and all the way back down. I'm only talking about half of that, so I've got to go 1.652 divided by 2. And that is going to be, and let's erase my little guy here so I have space. All right, so I'm going to go over my calculator, and it should still be on there. Yep, I'm just going to go divided by 2, 0.826. All right, so it's important, guys. We can't mess that up. Hint, hint. Don't mess that up on the test. Hint, hint, hint. All right, so I know then that VF is going to be 0. VI stays in. 9.8 obviously stays there. And then 0.826 becomes my delta t. So 0.826. All right, so let's go ahead and multiply my 0.826 times 9.8 times 9.8. I've got 8.0948. All right, so that's 8.0948 8 minus VI minus 8.0948 equals 0. Now I'm trying to get VI by itself, so I'm just going to add 8.0948, 8.0948 to both sides. And look at that. I'm going to get VI equals positive 8.0, and I'm just going to go ahead and round that to 8.09 meters per second. All right, cool. So that's the initial velocity. That's how hard I threw the ball. That's how fast it was moving the moment it left my hand, was 8.09 meters per second. Now it says calculate the distance from Mr. McSparron's hand to the highest point. All right, so if we want to know, if we want to know the highest point, that sounds to me an awful lot like Y max. All right, so we'll say, actually, I'll take that. Let's put it over here. All right, and we'll say Y max is our question mark. That means I have to use the Y max equation, which is Y max equals 4.9 times delta t squared. So that means I need to know delta t. Delta t, what was my delta t? Well, I looked up here, and delta t was that, 0.826. Remember, we're only talking about the time to the highest point. We're not talking about it coming back down. That's why I'm still using half of that time that I found on LoggerPro. All right, so 0.826, we're just going to take that. We're going to plug it in right there. So I'm going to end up with 4.9 times Y max, 4.9 times 0.826 squared. So my 0.826, I need to multiply it times itself. So I'm going to go over here, and I'm going to go clear, and we'll go 0.826 times 0.826, and that's 0.682276. Now, same as I did in the last problem, what did I say? It was 0.682. All right, so I'm going to write down 4.9 times 0.682. I'm not going to write down the whole thing, but I am going to leave it all on the calculator. So when I go over here, all I have to do is go times 4.9, and I get my max height, 3.34 meters. All right, so that's Y max. Y max equals 3.34 meters. And there we go. There's my answer. That's the distance from the hand to the highest point. All right, so draw the following graphs for the motion of the ball. So position versus time. So notice this. It says that position doesn't need numbers, but velocity and acceleration do. All right, so if we remember position versus time, we know that if it starts off at 0, okay, that it's going to go up and it's going to go back down. All right, so our position versus time for up and down is going to look something like that. Now, velocity versus time gets a little bit more tricky, okay, because remember, I'm going to start off at a velocity, so I know my initial velocity, and so I'm going to need to label that. So my initial velocity is 8.09 meters per second. So that means this needs to go up to about 8. So I probably need to do something like 0, 2, 4, 6, 8, 10, and then something like -2, -4, -6, -8, -10, do that kind of thing. Okay. And so that makes sense. So I know that my starting point is going to be at the very beginning when time is 0. I know I'm going to be just a little bit over 8. Okay, so right about there. Now, I also know this. All the way up and all the way down takes me 1.652 seconds. Okay, so I need to split this into about, come on, zoom in. Zoom in, there we go. All right, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. I want to split this into about 2 seconds. So let's make each of these, so let's make like that 1, that 2, so that's going to be 2, 4, 6, 8. Yeah, so this is going to be like 0.2, 0.4, 0.6, 0.8, 1.2, 1.4, 1, oops, 1, oops, let's go back. 1.6, 1.8, and 2. Okay, now here's what I know, guys, that it takes a little over 1.6 seconds. No, all right, we got that, 1.65 seconds. And at the very end, the velocity is going to be the same as at the beginning, but negative. So instead of positive 8, it's going to be a little bit below negative 8. So I'm going to go a little bit below negative 8 and a little bit past 1.6. Okay? So see that? So see I went a little bit below negative 8 and a little bit past 1.6. That means that at that final time of 1.652, the ball should be going a little bit more than negative 8 meters per second. All right, now here's the last thing I do, guys. I'm just going to connect that with a straight line. Boom. All right. Nice. And also let's notice this, that they didn't label this. So time was in seconds. And this was velocity in meters per second. Time was in seconds. This was position in meters. All right, cool. Now, acceleration. Easiest graph you'll ever flipping make, you guys. Easiest graph, okay? All you do for acceleration is you go -2, -4, -6, -8, -10, and right at -9.8, you put a flat line because acceleration is always constant and it's always -9.8. Let's not forget seconds and meters per second squared, and we're all set to go. There we go, guys. That's the key.